Hi everyone, welcome. We're still doing the control test from Limpopo. This is a provincial past paper, test 1, 2022. Yeah, so for previous videos, we've done question 1, we're done with that. We've done question 2, check other videos, and then now we're going to be doing question 3, right? But we're going to divide question 3 into 2. So this is the first part of question 3 that we're going to be doing for this video, and the second part of question 3, let me just quickly show you. This is how the second part of question 3 look like. Let me just wrap this off. This is how the question 3 look like. So we're gonna go through in details. This is really a nice question. So question 3 is gonna have 2 sessions. So check it out. This is the first session, and then we're gonna have second session, and after that we're gonna go to question 4. This is how question 4 look like. So yeah, let's go. Question 3. Question 3, the first part of question 3 says, consider the following geometric sequence. And they tell us you have sine 30, you have cos 30, you have 3 over 2, dot, 81 square root of 3 over 2. So before we answer this question, I think we need to do a revision on geometric sequencing. The nice thing about geometric sequencing, as also arithmetic sequencing and series, is we have this already in our information sheet. Our information sheet, they tell us exactly this equation that we need to remember. So we have the arithmetic equation on our information sheet, and we talk about that this is on our previous video. We mentioned this, that this is your sequencing and this is your series for your arithmetic arithmetic sequences and series. And then for geometric series and sequences, this is a formula for sequences. And then this is, so with geometry, there's 2 formulas you need to remember depending on your R. We're going to talk about what is R. So if R is not equal to 1, you can use this one. If R is between -1 and 1, you can use this one. So there's 2 formulas for series that you can use. So basically what we're saying is you have a little bit of notes. So we have a general solution, which is Tn is equal to AR power n minus 1, right? Remember, again, A is your first term, and then R in this case is second term over the first term, right? Which is also can be equal to the third term over the second term, and so on. So that's basically your R. This relationship is important. On your previous video, I've mentioned about D, the difference, which is D, which is second term minus the first term, which equal to the third term minus the second term. And I mentioned that this relationship is important. They're always going to test you the knowledge about this relationship. You need to always remember this, right, when you're solving your question. Right, so yeah, so that's your R, that's your A is the first term. And yeah, so that's the formula for series, I mean for sequences. And the formula for series, it really depends on what you're talking about, right? So if you are talking about n terms, if you counting series to n, so if you have t1, let me write it black, if you have t1 plus t2 until the last term tn, right, then you can use the sum of the n term. So you can use this formula. This is how normally I look at it. You can use this formula, so which is a power r power n minus 1 over, is it r minus 1? Yes, right, you can use this formula. But if you have so this is fine, but if you have t1 plus t2 until infinity, right, then you can use this formula, the sum to infinity, summing to infinity, which is a over 1 plus r, right? Of course, just check if r is not equal to 1. Also just check if r is between -1 and 1. Okay, so that's basically how you would look around your series. But then let's answer our question. So this was just quick recap on geometric sequencing and series, right? So, but then here in question 3, they say consider the following geometric sequence. And so you have our first term, you have our first term, you have our second term, you have our third term, and you have our last term, Tn. Now determine the number of terms in the sequence. And remember in our previous video, I've mentioned that when you talk about terms, we talk about n. So terms in number pattern, that's n. So basically here they want us to find n. Determine the number of terms in the sequence. Determine n in the sequence, right? So meaning, so we know this is the last term, right? Tn. So we know for sure this is our last term. So we know for sure that the last term is 81 over 3 square root 3 over 2. That's the last term. So we need to find n, and we know that the general formula for geometric sequencing is Tn is equal to ar power n minus 1, and we know our first a is our first term, so it's sine 30 degrees, and then r is second term over the first term, which is cos 30 degrees over sine 30 degrees power n minus 1. And we know already that the last term is 81 square root of 3 over 2. Okay, and then from here, so if 81 square root of 3 over 2, now it's up to you how you want to do this. I wouldn't really, you can use the calculator. That's what I want to talk about. If you want to use a calculator, you can do it with your mind. It's still fine. I will still recommend using your mind every time, right? So but you're looking for n here. We need to solve for this n over here, right? So what I would do from here, then I'll just divide by sine 30 degrees, right? Because we're trying to have only this. So if you divide by sine 30 degrees on both sides, so you have 81 root 3 over 2 divided by sine 30 degrees, which is equal to cos 30 degrees over sine 30 degrees power n minus 1, right? And then from here, it's a lot of ways of solving this problem. There's a couple of ways of solving this problem. I'll show you two ways. I'll show you using log functions. I know we haven't talked about logarithms. I'm showing you now because it's very important for you to know it. And then we'll show you using just exponents, right? Exponents. So there's two ways of doing this, right? So first way is log functions. So with the log functions, you're always going to pick the easy one. With the log functions, if you have something like this, we're going to have what you need to know is if we have a is equal to b power x, right? Log, let's just use log and ln is the same thing in retrospect, so just know log and ln is the same thing, natural log. So we're gonna just use natural log instead of logarithms, right? Ln, a is equal to ln b power x, which is equal to, and then ln b power x, that power there, that x gonna go down there, so this is equal to x ln b. Then from here you can solve for x, because now you can divide by ln b on both sides. Then your x is equal to ln a over ln b. That's basically what we're going to be doing here. So what you need to remember is, if you have a situation like, if you have a situation where you have if a and b power x, and they ask you to solve for x, just introduce the natural log on both sides, right? And then we know that the natural log of b power x, that power there, x, can be 2, can be any number, as long as an exponent, that exponent, bring it down, is the same as this. Okay, and then because you're solving for x, then you can divide by ln b on both sides, so you're going to have x equal to ln a over ln b. So that's exactly what we're going to be doing here. So we have this left hand side, you have this on your right hand side, so you can just introduce the natural log on both sides. So you have 81 root 3 over 2 sine 30 degrees is equal to still natural log of cos 30 degrees over sine 30 degrees, and then you have exponent of n minus 1, right? So you have natural log of 81 root 3 over 2. I mean, you can punch this in your calculator actually. If you, I think it's a better way of doing it. You can punch this in your calculator because we don't have to write all these numbers all the time. So you have 81 root 3 divided by 2, divided that all of that with sine 30 degrees, so you should get 81 root 3, right? And also with this one, cos 30 degrees divided by sine 30 degrees, so you should get root 3. That's actually much better. Okay, right, so from here then you can just bring in the exponent down. This is the exponent, n minus 1 is an exponent that we're bringing down. Okay, 81 root 3, and then because we're solving for n, so you can now divide by ln root 3 on both sides. Okay, so what you're gonna have is, let me wrap this off. So what you're gonna have is n minus 1 is equal to ln 81 root 3 over ln root 3. Okay, I mean, this, you don't have to write this bracket. N minus 1 is always going to be n minus 1, so you don't have to write the brackets. And you can take that negative 1 to the right hand side, becomes positive, so n is equal to 1 plus ln of 81 root 3 over ln of root 3. And that's your answer. I mean, you can punch this in your calculator and see what you get, because remember what n, remember what n, the condition about our n, right? N should always be positive. It's a positive number, it can never be 0, and n is technically a positive integer, so it can never be a decimal or a fraction, right? That's how you know you've got your n, right? As long as you get a positive integer, then that's your n. So if 1 plus ln natural log of 81 square root of 3, punch that in your calculator, over ln square root of 3. So your answer is 10. That's what I'm getting. I'm getting 10. That's 10. So what does this mean? It means that the last term here is, it's not t, just tn, but is t10. So the terms, they go from 1, 2, 3 till 10. That's our last term. Okay, so that's how you do it with natural logs. That's how we do it in natural logs. And what you need to know then, we can do natural logs, and then I mentioned that we can do exponents. We can go back what we have here. We can still punch this in a calculator if you remember. You don't have to write this whole thing. 81 over square root of 3 divided by 2, divide that by sine 30. We got it as 81 square root of 3 is equal to cos 30. I think that was square root of 3 over sine 30. Yes, square root of 3 power n minus 1. Okay, that's what we have. So using exponent, it's not as, so what you want to do is you want to have a position where you could, let me just give you an example, right? So if you have 2 is equal to let me make it this way. If you have 2 is equal to 2 power x, and then you need to solve for x, right? What we have learned with natural log is you can just introduce the natural log on both sides, and then you solve for x. Okay, that's the easy one. X is equal to natural log of 4 over natural log of 2. Easy peasy. And that's your answer. You can punch this in your calculator. You can punch this natural log of 4 divided by natural log of 2. You should get your answer is 2. That's your answer. Okay. That's natural log. Easy. Right? But you can still use your exponents, your information that you know about the exponents. So if you have a situation like this, what you're going to do is you want to find a way that you have your base as 2. So your base has to be equal. So this is your base. So you want to have also your base to be equal to this base, to be 2. But then it's going to be 2 power something, right? This is something that you need to find. And that 2 power something and is equal to 2 power x. Now, the rule is if 2 bases are equal, therefore the exponent are equal. That's basically your answer. Easy. Doesn't need a lot of questions. Just need you to think a little bit. So the way you do it, you don't have to really, if you don't have to really crack your mind. You can just start from, you can just say 2 and then have 2 power 1. And tell me if you say 2 power 1, do you get 4? If not, then that's not the one. If you can just do that increment like that. 2 power 1, do you get it 4? Nope, it's 2. Okay. 2 power 2, what do you get? 4. So that's the one. So 2 power 2 is equal to 4. And then you have 2 power x. So bases are the same. Therefore, exponent should be equal. Therefore, 2 is equal to x. So x is equal to 2. Boom. That's how you solve it. Make sense? So that's what you're going to be doing here. So first thing first, I see there's root 3 and root 3 there. I see I can do something with this before I jump into this. So what I'm thinking to do here is I can divide by root 3 on both sides. So you have 81 is equal to, because I mean root 3 over root 3 is 1. So and then with this one, we know for sure, right, that a over b, let me put it this way, a over b power n minus 1, I'll write just power n. This is equal to okay, the same. It's very important, bases are the same. So a over n power a power n over a is the same as a power n minus 1. So this is 1. So if you divide the exponent, if you divide these two same numbers, then you minus the exponent, right? But if it was a power n times a, this would be a power n plus 1. So if it's a multiplication, then you add exponent. If it's a division, then you minus the exponent. Okay, so doing the same thing here is going to be root 3 power n minus 1 plus 1, right? Because it's power 1 there, plus 1. So if 81 is equal to root 3 power well, negative 1 plus 1 is 0, so it's power n. Okay, and then again, now we can now do what you just learned there about exponent. So we're looking for a square root of 3, so we need to have a base square root of 3 power something, right? That square root of 3 power something, it should be equal to 81. That's what we're looking for. So you can start from 1, obviously square root of 1, square root of if you punch in your calculator, square root of 3 power 1 is just square root of 3, right? Now if it's power 2, that you're getting 3, so it's not 81. If you change that to power 3, you're getting 3 root 3, it's not 81. If you change that to 4, you're getting 9. Okay, if you change that to 5, you're getting a fraction. If you change that to 6, you're getting 27, so we're going somewhere. If you change that to exponent 7, you're getting 46.76. Okay, if you change it to exponent 8, you're getting 81. Okay, good. So square root of 3 power 8 is 81. Now what's happening? Bases are the same. So if bases are the same, then you bases are the same, then the exponent are equal, so you get n is equal to 8. Boom, that's your answer. But this is wrong, 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 wrong. This is wrong. Why is wrong? Because the other time we get n is equal to 10, we should get the same answer, right? When you're doing a logarithm, we get answer is equal to n is equal to 10. Remember that. Now getting 8. So let's check. What did we do wrong? So this is fine. We've punched this in multiple times, divided by root 3, right? So this and this cancel. We have 8, 1, and then square root of 3 power n minus 1 plus 1. So this is very important. Again, I think I've mentioned in one of my videos about debugging. It's very important. It's a very important skill that you need to learn in mathematics, and that's what you are actually learning. You're learning how to solve problems, right? You're not learn you might not use this in the future unless you pursue a degree in data science like I'm doing. I'm potentially using one of these information in my work as we speak. But you know what I mean. But you may not be a data scientist or machine learning engineer, or mathematician or statistician or whoever is working in this field of maths and science. But you need to know how to solve problems, and that's what they're teaching you in high school. They're teaching you how to solve problems just using maths. So if you have this basic understanding to able to tell that you are wrong and go back into your problem and trying to figure out where you went wrong, this is a very important skill to have, right? And this is how you're doing it, right? We just had two solutions. We have two solutions or methodologies to solve the problem to get a solution, and the other one gave us 10, the other one gave us 8. So there must be something wrong here, right? It's either this one is wrong or the previous one is wrong, right? So let's say this one is wrong. Now let's check what we did wrong, right? I've already saw something that was wrong here. I know some of you have already saw there's something wrong there, blah blah blah, made a mistake, blah blah blah. But it's very important. That's why I have to make these mistakes so that you can able to see and identify how you can also do it yourself in your exam and go back and debug. It's very important when you're doing debugging, even when you're doing coding, because coding is part of the things that it's part of the skills that mathematics is teaching people to debug, to able to solve the problem. That's what called debugging. So you can go back here. Okay, cool. We agree this is fine. 8-1. And you say, okay, cool, the square root of 3 n minus 1 minus, oh, remember, it's a division. So if it's division, minus, not plus. It's a common mistake. It's, see, division, it's n minus 1. So it's not plus 1, it's n minus 1. So if minus 1 over there. Okay, so you have minus 2 there. Therefore, you have minus 2 here. Therefore, 8 is equal to n minus 2. Therefore, n is equal to 10. Voila. So that's basically how you're doing it. This is how you do it. Okay, this is how you do it. Yeah, so this is exciting. So we've learned a couple of things in this video. We've learned a lot actually. So yeah, so this is it. So what I wanted to highlight here before I go to the next video and show what we're going to be doing in this video, this is what I want to highlight. So we've already in the previous video we've learned about arithmetic, sequences and series. This is the formulas, and you've learned about geometry, and these are the formulas. This is the formula for sequences, and this is the formulas for series, and you know when to apply these formulas. If you have a defined finite number of terms, then you use this. If you have infinite number of terms, then you use sum to infinity. Yes, sum to infinity. Let me change this. This is a mistake. Sum to infinity. Then you use that because it's sum to infinity, right? So yeah, so this is what we've learned, and on the second video of question 3, we'll be doing this amazing question here for 11 marks. And with this one, it was how many marks? Was 4 marks. So if I was a teacher, I would definitely give marks on identifying this, and give marks on of course getting the solution, and give marks on solving this part of the problem. This is okay, of getting here, and then of solving, whether using logarithm or using exponent. I'll give you mark for that. So these are the 4 marks that you will get. Boom. Awesome.